what's up you guys, it's Harrison, and today we're going to be talking about math again. This is going to be the fifth video in a series of videos where I talk about complex numbers, and today I'll be going through with you some of the examples that I skipped over in the last video. So the last video I was also talking about graphing Argand diagram, so you're going to be seeing the same slides as in the last video, except that some of them I will skip past it faster and some of it I will delve in it in more detail. So let's just get right into it. So what we have here is the table again, and I'd just like to point out this which is very important. These equations here, they're not gonna come out in your formula booklet. They're not gonna come out in your question. It's just something that you're supposed to know and recognize at the back of your head. So you're supposed to know the relation between all this, and you're supposed to know what it's supposed to look like. So whenever you see this equation, you should already know what the shape is, and you should also know the equation in itself, because this is like the standard form that the equation is going to take. So I'll remind you about what these equations are later when we look at the questions, but just bear this in mind for now. So okay, so I'll be skipping these slides, so watch the previous video if you haven't already, because I talked about them more about in those previous videos. So okay, so what I mentioned in all these things is that everything here is following the equation that will give you a loci of a circle. So a loci of a circle, you're gonna get something that looks like this. So I've already put it in the form of z minus a equals to r. So there's a very nice bracket here, so we can easily see that a is 1 plus 3i. We can already see that r is 3. Like here, there's all the brackets thing already done for you. So but this is not gonna come out in the exam. We're not gonna do like everything nice for you. So the first thing you gotta do is change it into the standard form, and you can only change it into the standard form if you know what the standard form is anyway. So when you see something like that, so again, the standard form for this is z minus a equals to r. So so when they say sketch the locus of this, you can't straight away go this is 3 1 3 negative 1. No, you can't do that. You're not supposed to do that. You're supposed to change it into the standard form first. So the standard form, you see there's a minus here, and this minus is really important. So so from plus, so we gotta force it to become a minus. So it's z minus negative 3. Minus negative 3 will give you a plus 3 anyway, and that's minus I, so you take out the minus, so it becomes positive I. So from here, now we have our standard form. So z minus negative 3 plus I equals to 3. So from here you can easily see that 3 is just your radius, and negative 3 1 is just your a. So we're able to draw a circle at the center of negative 3 1 with a radius of 3. So I don't think I mentioned this in my last video, but it's important to state the coordinates of your center, as well as like draw a radius and say that it is 3. So I mean that's important too. Okay, so let's just move on to the next example, which is a perpendicular bisector. So okay, so again, perpendicular bisector, it kind of follows this pattern where you see z minus a equals to z minus b. So there's two z's, we don't know what they are, and that's why it has this form. So okay, so a, yeah, you can clearly see this is a is 5,6 and b is 10,2. That's the point that it's gonna be at. So from there you connect them, and that's your dotted lines, and then you draw a perpendicular line, and that's your perpendicular bisector. So okay, like I said, it's not gonna be in the perfectly nice format. So if they ask you to sketch the locus of z plus 4 plus 2i modulus equals to z minus I, so what you gotta do is, again, you have to put in the negative sign on your own. Alright, so in this case, a becomes minus 4 minus 2i, and b is minus I. So maybe you might be thinking to yourself, oh, what's minus I? So what coordinates do I do? It's a, you can even look at it as z minus 0 plus I. Sorry for my handwriting. Z minus 0 plus I is the exact same thing. That's why you have 0 1. There's no real number there, so you can just say it's like 0. And of course on a side note, if you see z, obviously that's like z minus 0, which is just the origin, which is just 0, 0. There's no real part, there's no imaginary part, so it's just z, 0. I just hope that makes sense. yeah. So okay, so yeah, we have we have a phrase that describes the loci that we're supposed to see. You're supposed to see a perpendicular bisector, right? Of the 2 points, minus 4, minus 2. So that's our first point, minus 4, minus 2, and our second point, which is, oh, I don't know why it does this, which is 0, 1, and then you draw a dot, your dotted line, and then you draw a perpendicular sign, and then you draw a perpendicular bisector. All right. So finally we have our third form, which is argument. I made this slightly more difficult, so don't freak out when you see it. Just try to look at it. So I don't really know how to explain it to you, but this is this there's no z there, so you don't have to worry. This is actually just going to be a number, so you don't have to like freak out or anything. This is just a number. You just need to figure out what this is, and then after that you're going to get it. After that it'll be really easy to put it into standard form. Okay, so since there's no z there, just don't freak out. I kind of put that there to kind of trip you up a little bit, but yeah. So Argand, let's just deal with this first. Argand 1 plus I. Argand 1 plus I is actually tangent inverse. I mean, we look at it, it's in the first quadrant, so obviously it's tangent inverse 1/1, right? And okay, I'm just doing the right hand side thing here. So this is right hand side, so I'm just looking at the right hand side here. Alright, so Argand 1 plus I, right, is tangent 1/1, and there's no big deal, there's no need to modulus, no need to alpha or anything, because it's in the first quadrant, and 1/1 is 45 degrees, that's pi over 4, so easy peasy. Alright, so the only other thing you need to do, which is on the left hand side, which is we have to change it into the form of z minus a as usual. So hang on. Okay, never mind. So it's not in the form of z minus a here, but oops. Okay. So z plus 4 minus square root 3i. So you can take out a negative sign. So plus 4 becomes negative 4. Minus square root 3i, it becomes a plus square root 3i. So so hence we have this coordinate is minus 4, comma square root 3. And there we have our minus 4, comma square root 3. Alright. Okay, so something that I didn't take care to do properly in this diagram is that this thing has to be a dotted line. This has to be a blank circle. It's just a few things that you need to know when you're graphing this diagram. So dotted line, circle, this line, and of course you need to put this as pi over 4. So other than that, you should be good. Of course, and all these little nitty-gritty things. Yeah, these are some things that you need to remember, but graphing on the computer is a little bit different. I may forget these things from time to time. Okay, so this is challenging in a different sort of way, because this is because we in this question they didn't tell you had to figure out what's Argand 1 plus I for yourself. This one you don't have to. This one requires you to remember some of the things that you can or you can't do with an argument. So if you remember, like way back a couple of slides, let me just try to find it for you. Way back a couple of slides, you can see there's this thing that you can do with argument and you can't do with arguments. Yep, this is the slide indeed. So you can see argument, if there's a product, you can actually split it so that you're adding the whole arguments together. It's just like logarithms. So this is a bit of a flashback. So this is something that could happen in the exam. Maybe it doesn't happen, but now once I show you that slide and we come back to here, maybe it might give you some ideas. So what we can see is, okay, Argand 2iz. So we can actually split it up. We can even say, Argand 2i plus Argand z, and you can just start going from there. You can even split this up into Argand 2 plus Argand I, if you want to. But I mean, if you want to, you just have to see it's the same, but Argand 2 is 0 anyway, and Argand I and Argand 2i is the same thing anyway once you plot it out. So I'll leave you to investigate that for yourself, but meanwhile I'm just gonna tell you a little bit about how you can plot simple things like 1 Argand 1, argand minus I. It's very straightforward. Just draw it out. It won't take very long. So argand I or 2I, right? It's actually the points here or here. And either way, you're just going to start from the real axis and then just make your way up and just draw a little angle there, and you can immediately see it's pi over 2. There's no tangent inverse or what kind of thing you need to do. Just draw your diagram. Also because like tangent 90 degrees, you know, it's undefined. So yeah, I'd rather you just draw it out and you can see it for yourself. So yeah, speaking of which, argand 2 is right here. It's just on like the horizontal axis, so that's why you're gonna get 0. And that's also why argand I you're gonna get just pi over 2. So mystery solved. So okay, I'm just gonna clear it up a little bit. So argand 2I plus argand z, so we get pi over 2 plus argand z. So what you can do after this is you rewrite the whole thing. So argand 2iz equals pi over 6. Okay, fine. So we already found out what argand 2iz is, so we just rewrite it. Push the pi over 2 over to the other side, and finally we have argand z is minus pi over 3. So okay, on the side note, argand z is the same as argand z minus 0. Model z is the same as z minus 0. It looks obvious when you put it like that, but you need to understand the implications, which is z minus 0 is a circle. I mean, if it equals to something, I suppose. It is a circle that starts at the coordinates 0, 0, which is the origin, and argument z minus 0 is also something that, you know, the angle starts at the origin. Okay, so so let's just draw it, because I haven't drawn it yet, so let's just draw it. So we have our origin to like 0, right? And it makes an angle of negative pi over 3, so that's about 60 degrees. Let me draw. This is pi, negative pi over 3, and you know it's hard when it's hard to draw the horizontal line. So I guess in this case you don't really have to, because there's already a horizontal line on the real axis, so it's kind of weird. But you know, otherwise you should draw it. Okay. Another so-called challenging example, again, is something. The challenge here is to just change it into your standard form, right? So in this case you have iz plus 6i minus 4. You know, it's a little bit tricky, but you kind of have to go back to the fundamentals, which is what is I? I is the square root of negative 1, right? So in that case, I square is negative 1. So let's just explore that in more detail. So let's forget about the 2 first. Let's just look at what's on the left hand side. So our mission here is to just change it into the standard form. Again, z minus a equals to r, right? So iz plus 6i minus 4, we're trying to take the I out of everything. So it's quite simple with the iz and the 6i, but for the minus 4 it's a little bit tricky. So what we're going to do is take out negative 1, alright, and then with a negative 1 we realize that negative 1 is actually I squared. So if you can't do this at all, you just have to take out a positive 1, or you could just, yeah, you can just take out a positive 1 and call it I4. If you have no negative 1, you can just do this. Okay, so iz plus 6i plus I squared 4. So after extracting out all the i's, you get something that looks like this. So because of one of the things that you can do with modulus, I explained that in the previous video, you can actually split it into 2 parts. So what you're looking at is modulus I and modulus everything else. And this is just to take out, you know, your minus, to make it into the form of z minus a equals to r. Alright, so okay, so finally we have this. We can just jump right down to this with all the manipulations we already did on the left hand side. Alright, so and then modulus I is just 1 because it's just I. It's I. I is the points. Okay, let me just draw it out. Okay, see, we have this here, right? I is the points 0, 1, and 0, 1 is 1 unit away from the origin, so we just have 1, and then okay, so this is done, so we don't have to worry about the 1. Okay, so we have minus 6 and negative 6 and negative 4 as the center of the circle, and it has a radius of 2, and we're done. Alright, we are done with this video. Alright guys, thank you so much for watching. If you found this video helpful or you want me to explain something more detailed, just comment down below. Also, I'd like to know what other math topics you have trouble with. I really want to create math videos that I want people to watch. I want them to get something out of it. I don't want them to just watch things that they already know. Or if you have any other questions like how to do with school, how to do with schoolwork, or I don't know, anything in general, maybe something about coding or whatever, just shoot me a comment down below, and I'll just be happy to answer your questions. Otherwise, thank you so much for watching. If you found this useful, please like it and share it with a friend, and if you can, just click that subscribe button, and I'll see you on the next video. Okay, bye guys.